All right, we're about to learn about the difference between elements, compounds, and mixtures today. Before we can, let's do a little review though. True or false, an element is a pure substance. Hopefully you answered this as true. And next bell ringer, true or false, elements can bond with each other to form molecules. True again. True or false, compounds and molecules are the same thing. This is false. We're going to learn today that they have a distinct difference. All right. That was not supposed to come up yet, I don't think. Oh, here we go. The difference between molecules and compound. A molecule is the smallest unit of a compound that can retain its characteristics, the smallest particle of a substance that remains the same as the chemical, a group or likely different atoms held together by a chemical force. So these can be the same molecule, like here we've got oxygen plus oxygen. So these are just two elements bounded together, or most of the time, more than two. A compound, though, is different. A compound is a molecule, but it's a specific type of molecule that contains atoms of different elements. So here you can see we've got carbon and two oxygen. We have two different atoms, so this is a compound. All compounds are molecules, but not all molecules are compounds. Let's start right here. Scientists classify matter into one of three categories: elements, compounds, or mixture. We're going to learn about those different categories today, so make sure you copy down that definition. It's a lot of writing today, but I know you can do this. So first we're starting with elements. We've already talked a lot about these boogers, but if you haven't caught on just yet, elements contain only one type of atom, just one singular. Elements cannot be broken down into simpler substances by either physical or chemical means, and elements either exist as atom or molecules. Elements, again, are pure. They are pure substances. They don't contain they only contain one type of atom. For example, oxygen is just one element, but when I do carbon dioxide, we know we've got one carbon and two oxygen, so that is no longer an element, that's something else. Here are some examples of an element. We've got O2, which is oxygen. We've got H2, which is hydrogen gas. We've got fluorine, sodium, and boron here. So we could list them like this as examples, or we could have pictures. As you can see, these circles are just circles, all by themselves. Triangles, just triangles, all by themselves. And here we've got two circles bonded together, but because they're both circles, it's still considered an element. So here, this bottom picture is molecules of the same type of element. So again, because it's two of the same element, we still consider it an element. But compounds, again, remember, are a little bit different. Compounds contain atoms of two or more different types of atoms, so we're not talking just oxygen bonded to oxygen here. We are talking about maybe oxygen bonded to carbon, or perhaps oxygen bonded to a number of other things. Many times our compounds are more than just a couple atoms. They're usually long strains, especially once we get into the organic chemistry spectrum. They are often bonded together in a specific ratio, meaning like if we're doing carbon dioxide, I have one carbon for every two oxygen. Or if we're talking about water, I have one oxygen molecule bonded for two hydrogen molecules. Compounds can be broken down into simpler substances, elements by chemical means, but not physical means. Compounds have different properties than its component elements. So my compounds might react differently to things out in nature than my typical element. All right, here's some examples of compounds. See, we have H2O, we've got two hydrogens, one oxygen. We have NaCl, one sodium, one chlorine. We have one potassium, one chlorine here. And then this molecule, hopefully you've recognized this guy by now, C6H12O6, which is glucose. Here we've got some examples. We've got that Mickey Mouse-like ears here, which could identify as H2O. But you can see that we've got two different types of elements here, same here and here. And lastly, we're going to talk about mixtures. Mixtures contain two or more substances, either compounds or elements that are not bonded together. So these are not bonded. Elements and compounds are bonded together. These can be separated by physical means. They retain many of the same properties as its components, whereas our compounds did not retain the same properties. They reacted differently. Mixtures will react in the same way that their components do. For example, salad, Kool-Aid, and pizza and air are all mixtures. They have their different parts, but I could pick off the pepperoni of a pizza or the sausages if I didn't want them. Same with Kool-Aid. We've got the Kool-Aid packet as well as the sugar and the water, but I could separate all those out using evaporation and maybe a strainer. Here we've got a mixture. You can see they're not bonded together here. This one is a little bit clearer as well. We've got two bonded together and we've got one that's not bonded. So we do have some bonding, but not between the two molecules here. And here we've got even more of a difference. We've got those Mickey Mouse ears with some of our triangle molecules bonded to some O's. But again, these aren't bonded together, so they are not considered compounds, only mixtures. So now we've got a little bit of a brain checker here. Is this a compound, molecule, element, or mixture? Hopefully you're able to tell me a mixture. I can pick off the different little pieces. Like I really like these little brown pieces of bread right here in Chex Mix. That's usually what I eat first, so I pick those out. I don't really like pretzels. Usually I just throw those away. All right, what about this? Is this an element, compound, or mixture? This is a molecule. We could have also classified it as an element because they're all the same type of elements. What about this one? We've got carbon, element, compound, mixture, or molecule. Hopefully you were able to tell me this is an element. We've got salt and pepper. What do you think? Molecule, compound, element, or mixture? Hopefully you're able to tell me mixture. I could simply sort out the pepper from the salt based on color. What about this guy? A compound, because we've got two different types of atoms right here. And that is it. Have a great day, guys. Do your notes, and I will see you next time.